In lesson 3.6, part 2, we're going to look at graphing our lines in the coordinate plane. We're going to take a look at lines written in the different forms and how we would graph them. The first one, we're looking at equations that are given in slope-intercept form, which we talked about being y equals mx plus b. And the easiest way to graph a line in slope-intercept form is to first graph the y-intercept and then use the slope to find two other points on the line. So if we are given our equation of y equals 3/4 x plus 2, I'm going to want you to first identify the slope. We know our slope in this case would be the number in front of our x, 3/4. And our y-intercept, the value for b, would be a positive 2. The y-intercept is our starting point. We know that if it is at 2, it is really the point 0, 2. And so we're going to put our first point there. It is from our y-intercept where we use our slope, our rise over our run. Because this slope is 3/4, we know rise over run. We are going to rise 3 and run 4, meaning up 3 over 4. And we put our point. From there, again, we're going to go up 3 and over 4. Once we have our 3 points, we're going to take our straight edge and we're simply going to connect. Now we are graphing the line, and so technically it extends forever in both directions, and we would put our arrows on the end. I can see that this one has a positive slope. From moving left to right, it's going uphill. In the second one, very similar, but this time as I identify my slope, I see it is negative 1/3 with a y-intercept of negative 2. So this time, my starting point at negative 2. So again, I'm going to find my y-intercept and plot my dot. From there, I'm going to use my slope, negative 1/3, meaning down 1 over 3. Now, just because we went down, we are still going to move to the right, but we could go the opposite direction. So I could go up and left. I have my 3 points. I am going to take my straight edge and connect. And we have graphed our line. Looking at page 2, we're going to talk about our equations given in standard form. And one way to graph your equations when they are given in standard form is to take a look at finding the x and the y-intercepts. When my equation in A reads negative 2x plus 4y equal to negative 8, I cannot quickly identify the slope. Now, when we take a look at graphing or finding our x and our y-intercept, I'll remind you what would it be like if we had a teacher. And I know for my y-intercept or my x-intercept, it would be when I have zeros. Right? Now, my x-intercept, I know my x-intercept is really when my y-coordinate would be a 0, so I'm going to substitute that in it. It makes it pretty easy to solve because 4 times 0 is just going to be 0. And I'm going to think about dividing by negative 2, and we would find that x is 4. So my x-intercept would have to be the point 4, 0. Now when I go to find my y-intercept, I'm still using this equation, but now I'm going to plug in a 0 for my x. And so 0 times negative 2 is going to be 0. Plus 4y equal to negative 8. dividing by 4, we would find out that y equals negative 2. And so my y-intercept would be at the point 0, negative 2. Now I can go ahead and plot those points. Using my intercepts, I am only going to have 2 points, my x-intercept at 4 and my y-intercept at negative 2. Once I have those, I'm going to take my straight edge and connect. Second equation, we're going to use the same strategy. My x-intercept means I'm going to plug in a 0 for the y, which would mean 5x minus 0 equal to 30. We would divide by 5, and we would find out that x is 6. And so my x-intercept would be at 6, 0. Finding the y-intercept, we would need to plug in a 0 for x. Divide both sides by a negative 6, and we would find out that our y-intercept would be at 0, negative 5. So again, we're going to plot those 2 points. 6, 0. 0, negative 5, and connect. Now there is another strategy when given an equation in standard form. If I don't want to find the intercepts, the other thing that I can do is I can transform that equation into my slope-intercept form. So I can solve for y in order to find my slope and my y-intercept. So if I were going to do that, equation A, negative 10x plus 2y equals negative 6, in standard form, I can't identify my slope, but I'm going to work on solving for my y value. 2y equals 10x minus 6. Divide by 2. And we find out that y equals 5x minus 3. Well, now I'm able to identify a slope of 5 and a y-intercept of negative 3. And so instead of using the x and y-intercept, I can now use the y-intercept and use my slope of 5. We know a slope of 5 is really equal to 5 over 1, so I'm going to go up 5 over 1. The equation in B is much the same. I'm solving for y. This time I'm going to add 6x to both sides. I'm going to divide by 3. Here I find out I have a slope of 2 and a y-intercept of 4. So my y-intercept is my starting slope of 2 up 2 over 1. Sometimes you'll find that your line does go off of your graph, and you may have to extend your graph a little bit. You may also have to count by 2s or by 5s by changing your interval. Lastly, we're going to take a look at equations that are written in point-slope form. And when my equation is written in point-slope form, the easiest way to graph is to first graph the point and then use my slope. So if I'm given my equation y minus 2 equal to negative 3 times the quantity x plus 4, I want to be able to pull out the point on my line. The point on my line is the x1, y1. I can see here I'm going to have negative 4, positive 2. That is the point on my line. That is my starting point. I can see a slope of negative 3. And so I'm first going to graph my point, negative 4, 2. From there, I'm going to use my slope of 3, or negative 3 over 1. So I'm going to go down 3 over 1. And then I will connect. In equation B, I can see the point on my line would be positive 2, negative 3. Again, it's the opposite signs with a slope of 1/4. So I'm going to start at my point, 2, negative 3. I'm going to go up 1 and over 4. And then use my second edge. Lastly, we want to take a look at graphing the equation x equals 3. Sometimes it's hard to remember, how do I graph an equation where x equals 3? Well, if you think about your t-chart, if x equals 3, I'm picking points, but my x value always has to be 3. I could pick 3, 0, 3, 2, 3, 4. When we come over here to graph, 3, 0, 3, 2, 3, 4, we start to say, oh, yes, x equals 3 is going to be a vertical line. When I look at y equaling negative 4, again, if I'm not quite sure, thinking my t-chart, my y value would always have to be negative 4. So y equaling negative 4, I could have 0, negative 4. I could have 2, negative 4. I could have negative 2, negative 4. But I can see that y equals negative 4 is going to give me a horizontal line. What we've actually just graphed, 2 equations on our one graph here, we have a system of equations. If you remember from earlier in the chapter, we solved the system of equations by using elimination method. But in this case, my system of equations, the solution found on my graph, would actually be the intersection point. My intersection point of 3, negative 4 would be the solution to my systems of equations. If you have more questions on graphing lines, please stop in and see me, and I'll be happy to go through some more examples.